Right. Hey everyone, welcome to the stream. So let's see what we have to do today. We'll continue building the Mario program that we were building previously. Let's go into Mario folder. But before that, I think we need to open up the VM emulator. So let's do that. Nand2Tetris tools, VM emulator. Okay, let's try to load the program. Mario. I think we should load the folder directly. Yes. No animation. Let's run it. We have got the character, but let's see if it works or not when I press the right arrow key. So it doesn't seem to be working. So that was what we were getting earlier. So let's try to debug it. We should open up Mario.check, I guess. Is the music too much loud? All right, let's see. Move Mario right by 16 pixels. So it was working previously when I didn't wrote this condition. So let's check. Let me comment it out first. And I think we need to compile it again. So for that, I have to go into Nand2Tetris tools. Is it inside tools? Do we need a Jack compiler? Yeah. So let's fire up the Jack compiler, and we have to give the folder. Let's see, Mario as an input. Okay, it did compile. So let's reload the program again. Yes. So we are getting the character. Now if I press the right arrow key, see it is moving right, but let's see, when I try to uncomment this again, it won't work. So we have to figure out how to make it to work for this condition. So this condition basically checks if the character is moving outside the screen or not. Don't want to move it outside the screen. If it does, then it will result in heap overflow. Yeah, I think I should check out this slide. Yeah, I was looking for this figure. So what this condition does is, if it checks if location is less than 7649. So what is 7649 anyway? 7649 is the register inside this memory map. So it starts from 0 up to 8191. And let's see, 0 to 31 registers will map to row 0, and next 32 registers will map to row 1. So when I say 7649, not 7649, what am I passing to this draw? Location, where's the location? Okay, not passing it inside this folder, inside this file. And to open up, let's see, the games object. Am I passing the location? Yeah, I'm passing it inside this file 7648. So I'm passing 7648 as the register location. So let's see what happens when I pass 7648. So the register, the row, wait, I forgot. Okay, so the register 7648 maps to a row somewhere around this. And I found out the 7648 value using this equation. So let's see, I placed 0 for the column, I guess, and for the row, I think 32. Okay, let me divide 7648 divide by 32. So 239. Okay, so the 76448 value maps to 239th row. Okay, I get it. Now we are passing 1616384 plus that value 7648 to the memory address to draw the sprite or the Mario character. So this is what will happen. It will draw it at this location. This is the top of the head, aligns with the 7648 register value or the 239th row. Okay, but now what we want to do is, when we press the right arrow key, this should move to the right, but only if this condition. So I want to somehow figure it out how to not allow this character to go outside this boundary. So I tried to use this condition location less than 7649, only then move the character. But it doesn't seem to be working somehow. Is this not a valid syntax for if? So in this Jack language, I do have to use two brackets so that it will first evaluate this, then it will check for if condition, because this language Jack doesn't have precedence and what is it called, associativity and all that for operators and syntax. So we have to explicitly give the precedence or associativity, whatever it is called. Well, it seems this syntax works as well without the braces. So let me try to do that. I think it was not working for that condition as well. Anyway, let's try to. Good. Let me remove this extra brackets. We'll have to recompile it. Let's load it again. Yes, please. Let's run it. Let me press the right arrow key. Nothing seems to be happening. So that means there's no problem with our syntax of if, but just the condition. So does that mean wait, does that mean we are not getting inside this condition? So the only case when that should be happening is this location is not less than 7649. Oh wait. I get it now. So the location initially is 7648. Why am I checking for 7649? This is incorrect. Okay, I see. So what should be the value here? Let's see. 7648 plus 511. So if 7648 is, so let's see, let's forget about 7648 value. Let's say I'm giving 0 as the value. So now when I'm incrementing it by 1, it should stop at this point. Okay, let's see. Plus 30. So 7648 plus 30. How much is it? 7678. Yeah, I think so. So let's give 40 plus 30 is 70, right? 7648 plus 30, 7678. Okay, let's try to test this new value. Oops. Let's stop it. Let's load the program again. Yes. I think it will work this time. Yeah, it is working. But it should stop at the boundary. Let's see if it happens or not. Yeah, it did. But it stopped at much earlier. We stopped much earlier at much earlier point. We need to stop around this point, I think. So let me add plus 16, I guess, plus 15. So 7678 plus 15. How much is it? Let's say 70, 80, 88, 93. Is it 93? I think so. Let's compile it again. Load the program. Yes. Run it. Let's see. Oh wait, why did it start over? Wait, is the screen a smaller than it should be? I think so. Okay, let me try to do something. So I think this screen is not exactly 512 pixels, because when I passed this rightmost boundary, the character started incrementing on this left side. So that means it was not displaying the whole memory map. Okay, the only way we can check it out is to implement this move left functionality. So let's do that. Well, it seems we do have the logic for left. The only thing we need to do, I think, is implement the mapping from key. So let's do that. I think it should be inside game.check. Where is it? Yeah, the logic is over here. So I should uncomment this line, and after this, let direction equal to 0. Okay, let's compile this program. Mario load. Yes. So it is moving on the right side. Yeah, it's moving left as well. So let's see what happens when we pass the rightmost boundary. So you see it appeared at the left side and it will stop at somewhere around this area. So I think it stopped, but now I press left. Oh, what the heck happened? If I press left again, it will result in memory error, I think. No, it didn't. It keeps on going on the left side. What the hell? Okay, I should write the condition for leftmost boundary as well. Where should it be? Let's see. Over here. If location, I guess, is greater than 7648. Yeah. Nope. 7648 plus 16. 7648 plus 16. How much is it? 7650. 64. 7664. 7665. Let's say 7665. Then only move the character to the left, or else don't. Oops, it's not even moving on the left side now. So our condition is not working. Why is it not working? So okay. 7648 is the leftmost register. 7648 plus. I see. Wait. If 7648 is the leftmost, then plus 16 will be let's see, 7648 plus 7650. How about 7650? Yep, this isn't working as well. Oh yeah, it is working, but it stops at this point. What? Oh, it works sometimes, but sometimes it doesn't. So the code is a bit buggy. What? Just keeps on going. What is happening? Ah, it stopped at this point. Now it is working for the left arrow key as well. Okay, it stopped at this point. Oops, it resulted in a heap or screen range outside of bounds there. Okay, yeah. So it seems that our conditions are not really working the way they should be working. Oh, fuck it. Let's try to create something else. By the way, I'm just playing around with this language, Jack. I don't really have a particular project in mind. I'm just playing around, so it doesn't matter if I complete a project or not. The point is to know how this language actually works, just to get familiar with the syntax, so it doesn't matter. Also, so that we can move to project number 10 again. I think we are going to build a compiler in project 10. Yup. So right now we are just getting familiarizing ourselves with this Czech language, so that in the next section, project section, we'll be able to build this compiler easily. Okay, should we try to create a, I don't know, maybe a character set or something, a font set, like a text editor or something, so that when I press a key, A, B, C, D or anything else, the text should appear on the screen. But for that, I think we'll have to create custom fonts like this for A, and the fonts will be 16 by 16 pixel. Let's try to do that. First, we'll try to create alphabet set. Let's just create a character. We'll keep it a bit thick. Okay, does this look like A? I don't think so. It should have like a it doesn't matter. Let's just get a straight A like this one. Straight lines. Okay, now we should have a horizontal line like this. Okay, this should work. So now we'll try to create this kind of fonts when we press the keys. Let me get out of this project first of all. We should create a new folder. Let's call it text editor. Text ed. Yeah, this name is good. Inside this text editor, let's get font, I guess. Font dot check. Let me copy the code from Mario so that we don't have to rewrite it. Mario dot check. Yeah, I will just copy all of it up to this point. Let's rename this class. We'll call it font, and for the constructor I think we should pass the character as an argument to the constructor, right? Or maybe not. No, it's not pass the character over here. We will pass it to a method. This will work. Dispose this method will be as it is, but I think this method draw, let's give it a name, draw display A. Yeah, this name is apt. Now we need to copy this code. Let's copy it somewhere around here. Cool. So, and we also need to pass the location. So this is a problem because we'll have to keep track of the location. Let's see, it doesn't matter for now. It doesn't matter. Let me delete this draw method. Okay, now let's see, do we need this other methods? Let's just keep them, and I think this should be a method, not a function. Okay, all we need to do is change this from function to method. Cool. Okay, let's see, we'll call this disp over here, disp A. Let's pass the location, as we are not passing the location in the constructor. Yeah, let's just pass the location. Instead of location, we have lock. Good. So now what else do we need to do? So this class is all right for now. What we'll do now, we need to get an instance of this class, but before that, hey man, what's up? Did you solve your bug? What? Not yet? So still doing figuring. So are you still online, or are you still streaming, or did you stop it? Okay, you stopped streaming. Okay, so what do you say? Should we? You're still coding. Should we try to solve your program right now? That will be a good idea, I think. You can do it together right now. Well, it's not a pain for me because I don't really like what I'm doing right now. So I think let's just try to solve your problem then. Let me open up your repository. It's this one, right? GPAT emulator. Yeah. Did you push the latest code? Okay, wait. Cool. So let me clone it now. Let me render. Which file should I run first? Is it renderer? Python GPAT. Okay, GPAT. Oh, what? I have to import all the libraries. Okay, you haven't written the cbang, I guess. Let me try to open it this way then. Import pygame. Oh, I have to install the pygame, I think. Let's try to create an environment variable environment. Yeah, I don't want to install it globally. Python 3. So it's env bin activate. Is it activated? Which Python 3? Okay, it is activated. So let me install the Pygame now. I hope it installed it in this environment. So let's try to open the program now. Python 3 chiplet. What? Ah, yeah. It installed it globally, yeah. Yeah, it's okay. I will remove it later. So let's see if this works or not. Okay, it is working. What the heck? Okay, do I not have the ROM? C8. Oh, there's no Pong 2. Okay. Where is it? Inside the CPU. So did you install any new ROM or what for Pong 2? Should I change Pong to Pong 2 to Pong? Wait, it is not here as well. Ah, yeah, you're passing the file name. From where are you calling this load ROM? Okay, then what should I do then? Git fetch origin master. Okay. Then you have one state changes. Please commit. Okay. So did I change anything or what? Oh yeah, because of the env. Oops. Okay. So I guess I have the Pong 2 now. Cool. So let me try to run it. Good. It is running. How do I move this? The arrow keys are not working. 1 and Q. Okay. What the hell? Why have you given this kind of keys for the navigation? It's hard to control it. Okay. Okay, yeah. You downloaded the ROM from the place. I got it. It's really shitty. Okay. Okay, let's see. So I think we should try to, I don't know, maybe try to read. Let me try to see how it actually works. Cheap accumulator. Yeah, sure. Chip 8.py, CPU.py. Well, I won't. I like to do head banging. What should I open first? Should I open CPU.py? From where should I start analyzing the code? CPU, alright. Okay, that's it. Okay, then what? Start from chip 8, okay. Down to up. What the heck? Chip 8.5, okay, let's see. What the hell? How do I stop this game? It just keeps on running apart. Okay, CPU import CPU. I'm not even familiar with Pygame and CPU. Let's just. Okay, it starts from main. You load sprites into memory, then you load the ROM. While true, CPU.cycle Pygame screen. Okay. Okay, if event dot type equal to key down, you pass the key, the event to keyboard dot pygame key down event. Then display update. Okay, after the key has been pressed, pygame dot display update. Okay, now let's read this CPU file. We have an init. We are passing the renderer and the keyboard. Excuse me. Renderer, keyboard, memory, 4 megabytes, right? 4 megabytes, or is it 4000? Okay, this B0 to 16, I0, delay time 0. Program counter is set to 200. Okay. Pause is false. Wait, okay. After that, we call this CPU dot load sprites into memory, right? So these are the sprites. Okay, so this by sprites you mean, what is it? The characters, the code for characters, or what? 0 up to F, am I correct? Self dot memory sprites. What do we do after that? We load the ROM into the ROM data. Wait. Numbers like 0, 1, 2, 3. Okay. Okay, so in the memory, the pedals. So this pedals are just one character, right? It's like one or something. How about this ball? Which sprite is it for this ball? Or is it just one? So first we load all the sprites. Okay. First we load all the sprites in the memory. After that we load the ROM data, right? Offset plus index. Okay. So offset. Where is this offset coming from? Okay, you are passing the offset here. When we, okay, let me go back to this. So here you are passing 200 as the offset, and if I remember correctly, this was the program counter as well, right? No, actually I like this stuff. Doesn't matter. It doesn't matter. Okay, so the offset is 200. So that's also the value of the program counter. Okay, good. Okay, so I guess that is the working memory stack. And but wait, if we pass 0x200 plus index, so 0x200 is in hex. So this will it convert it back? Wait, this sprites. Zero two, okay. Yeah, right. Zero x 200. So it is 512. 0x200 is 512. Okay, so we are reserving 512 space for the sprites, I guess. At 512 index, we start loading the ROM data. Good. What do we call after that? While true, we call CPU dot cycle. Okay, we call this function afterwards, and this function will continue in the range 0 to self dot speed. Okay, is the value of self dot speed? It is 10. So for 0 to 10, if not self dot pause, opcode is equal to self dot memory self dot pc. Okay, so it will take the first instruction from the memory, which is at OX200 or 512. And what is this? Is it shifting by 8 bytes, 8 characters? This is left shift, right? Left shift and ORing it with self.memory self.pc plus 1. Okay. So okay, let's just say this gives us the opcode, and we are passing this opcode to self execute instruction. So where is it? Execute instruction over here, and self dot program counter by 2. Okay, so let me open up chip 8. So all the instructions are of 2 bytes or something, right? The inside the chip 8 emulator. What's the Wikipedia entry? Okay. Wait, but why is it just showing 2 byte, 2 byte, 2 byte? Okay, so this is the first 2 bytes. Wait, I forgot. 1 byte is equal to how much hexadecimal values? Is it 1 byte equals to 2 hex code, right? 1 byte is equal to 2 hex code, 2 hex values. So this 2 byte, this 2 hex code values will map to 2 byte, and this 2 for this 2 hex values for another 2 byte. Am I correct? Okay, so and what we are doing is first okay, so this is the whole of the opcode. And over here we are incrementing the program counter by 2. Okay, after that we are opcode and 0. We get the opcode and we do the bitwise AND with 0x0f00, 0x0f00, 0f00, 3840. And we are shifting it. Okay, so suppose the opcode is let's say this, and suppose the opcode is 00E0, and we end it, and what will this give us? What? Okay, we get the hex. Wait. Do I have to get the int for both of them? Okay, it gives us 0. And what are we doing after that? We are shifting to the right 8 positions. It remains 0 for this. So what does this give us back? This value 0 and oh wait, yeah, it is giving us 0 0, right? So if we want this E0, then we have to do by 4. So let me do it by 4. Wait, no. Opcode and 00F0, 00F0. Oh wait, It's still giving us 0. It should give us E0, right? Let me try to pass 00E. What? What did I do wrong? Ah, yes, I get it. 0x. Good. And 00 E0. Why is it giving us 14? We want this value in hex as well. So let's do this 00xe. Okay, it's just giving us E for this. For EE, is it just giving us this third byte or what? Let's go back to code. X and Y. First hex is equal to opcode, and this last 2 hex. Okay. If the first hex is 0000, which is what? This. And if can we do like a video chat or something? Can I embed your video inside the stream? How can we do that? Is there a way to do that? It will be much easier if we were also on the video chat. Yeah, I saw the streamers do that as well. Well, I don't know as well how to do that. But it will be way much easier to communicate. Well, tell you what, while I'm reading this code, maybe you try to find a way. If you want, that is. If you are too tired, it's okay. I'm going to analyze this code anyway. So let's see. If the first hex is this and the opcode is this, then do clear. Okay, where's clear? This clear. Okay, so send me the article that you were showing earlier, the JavaScript one. Yeah, it's all right. We'll do it next stream. clears the screen. Okay, so this is the method. Clear, execute instructions. Yeah, thanks for the article. Yeah, right. How to create your very own cheap emulator before that. Cheap it with only 4 kilobytes of memory and 36 instruction. Okay. This will be very in-depth and long article in the hopes of making sense of everything. Self.render clear. Okay. The render is in charge of rendering the pixels in the display array. Test render chip 8, which is 16 keypad, hex keypad, 1 to 3 up to 9, 0 including and A, B, C, D, E, F. This is the key map or the sprites that we loaded earlier. One. We have V as well. F, Z, X. Okay, yeah. This is just mapping the key map. Oh yeah, CPU. We need to initialize a few specific variables within our constructor along with a few other variables. 4 kilobyte, 16 8-bit registers. Okay, we have 16 8-bit registers. A 16-bit register, this .I is to store memory addresses. What is it? Self.I to store memory addresses. Okay, it's like a memory address pointer. 2 timers, one for the delay and one for the sound. Program counter, the store's address currently being executed, and array to represent the stack. We also have a variable that stores whether the emulator is paused or not, and the execution speed of the emulator. Okay. Load sprite for will be referencing technical. Okay. This link doesn't seem to be opening in my browser. Oh. Chipet makes use of 16 bit 5 byte sprites. The sprites are simply the hex digits 0 to F. So see all the sprites with their binary and hex value. Using your code will simply store the hex values of the file. In order to run into memory, in order to run ROMs, we have to load them into memory, look through the contents, store it in starter location. Okay. What do we do after that? Did we load the ROM correctly? Okay, we did. Okay, we have taken care of this part as well. Cycles. So we look at something like this, or to give a few examples. So our job is to grab that code from memory and pass that along to another function that will handle the execution. What this does, first of all, each instruction is 16 bits, 2 bytes long, but our memory is made up of 8 bit, 1 byte. This is 16 bits, 2 bytes long. Okay, this means we have to combine 2 pieces of memory in order to get the full opcode. That's why we have .pc, this pc, and +1. Okay, it can just combine two 1 byte values to 1 byte values to get a 2 byte value. To do this properly, we need to shift the first piece of memory. I see. 8 bits to the left to make it 2 bytes long. Okay. Shifting x11 gives us x1100. From there, when we do the OR with this PC plus 1, the value of this PC plus 1 will be overwritten for this 2 bytes, I guess. Yeah. So suppose this is the value. After the operation is done, we'll have 0 1. No, not this. 0 1 0 F0. Okay, I got it. Lastly, we want to update our timers when our emulators is running, not watch, play sound and render sprites on the screen. Okay. Let's not analyze this code, it doesn't matter right now. So let's directly dive into this execute instruction. That's where the main meat of the program is. So let's see, this is the final function we need for the file. Okay, hopefully logic for all 36 bit. Let's look at this part of the section. NNN or address. Why the hell I can't open this? What? Fuck it. So NNN or address of 12-bit value, the lowest 12 bits of the instruction, and or a nibble, the lowest 4 bits of the instruction. 4-bit value. The lower 4 bits or 5 byte. We are talking about this and x and y values. Okay. So it seems this variables occur at the exact same position. X is always at this second byte and y is always at this byte. Is this correct? Yeah. So x is the lower 4 bits of the high byte and the upper 4 bits of the low byte is y. Yeah, so I was correct. And this NN or address a 12 byte value, lowest 12 bytes of the instruction. So yeah, these are the 12 bytes. And or nibble, the lowest 4 bytes of the instruction. Okay, this one. KK or byte and 8-bit value, the lowest 8 bits. So where is this used? KK. Where is KK? What? There's no KK. What is he referring to then? I'm at my home. What do you mean where I'm at? I'm from India, man. In terms, okay, all right. Well, I'm right now trying to read this post and I'm trying to figure out what this method execute instruction. So I'm just trying to read the info of this method. So I was reading this and I figured this part out, but I don't know what he is referring to when he says KK, because inside this instructions I couldn't find KK. So there's no KK in this instruction set. So do you know what he's referring to? Yeah, well, so I skipped most of the things because this update timers. All right, let's see how can we do that. Do I have its code installed? We can like audio chat on Discord, right? I don't use it much, so I don't know. Let me log in. Okay, I have already logged in. Let's see. No, if you want to talk, I'm up for it. It's always better to have a second hand or a second head. Yeah, I did hit you up. Can we like talk on Discord and meanwhile also have the audio come up on the stream? Can we do that? Hello. Let me turn off the music first of all. I don't know. Wait, let me turn off the music. Well, it's all right. You can talk on Discord. It will be easier. Hmm. Yeah, this one, this bit, KK. What is he referring to when he says KK or byte? Uh, it, it is an 8-bit value, the lowest 8 bits of the instruction. So, well, wait. Okay, yeah, sure. Hmm. My internet is going to freak out. So, when he says this KK or byte and 8-bit value, okay, so is it referring to this 2 bits? These 2 bytes, I guess. So, E1. What do you mean E? This, okay, I get it, all right. This, all right. So, right? 63, yeah. Mm-hmm. Yeah, I figured that out, but uh, let's just leave this one for now. So let's see. Yeah, sure, sure, sure. Go on, go on. Mm-hmm. Mm-hmm. Yeah, yeah. I already messed around with it, so I have it already. Wait, I messed around with it like this. So I already did it. Bin, yeah. Wait, do I have to convert it to int first, or it's okay? All right. 0x 00 e. Say that again. E0. All right. The binary value. All right. Yeah, right.
0x00f0, right?
Huh.
Yeah, 0x0f00. So try bin is 0x0f00.
0f00.
Zero. Okay.
Yep.
So you get that thing, right? So try ending it. So when you end,
Ending it with this, right?
so it will be something like I'll send you the code. It will be something like this.
Like this one, right? 0x
Um,
EE and
yeah, something like that.
yeah.
I think you'll get an error. I think
No, I just press the Control C.
okay.
So
So I'll send you the code. That's fine. I'll do it on my system.
sure, sure.
So X is right. After that we do bin. Right. So try this. Try this. Try this. If you FF is just like getting the last bit value of it. So if you want to just extract EO, I mean E0, you
Hmm.
just do FF at the end, so you just get E0. So if you check in binary, it will make more sense. So binary would be, I'll do it on mine so I can send it to you.
Yeah, so I get it because FF is 1, so it will end with this part only, and the
Yeah,
because of the logic of and it won't give us this value. It will give us whatever the value is at this location because of this FF. So yeah, I get it.
right.
This will give us the X part, and according to this instruction, X is the 4-bit value, which is the lower 4 bits of the high bar instruction. So that's
Right.
what we do. Yeah, so I get
If
it.
you if you look at this, so um there 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 fuck. So if you look at this, right, I'll show you. So look at this. Bin is 0, right? You get this
Hmm.
in binary, right?
Yeah.
After that, you get the F1 in binary. After
Hmm.
that, the answer is you get extract E0, right? So answer is this.
Yep.
Basically, if you line them up, I'll line them up for you. Okay, this right. This is for the EE. This is for the FF.
Yeah, I got that already. I
This for you
so I
see.
I have already worked with bitwise operation, so I know it is affecting this part.
Yeah,
So,
extracting this
huh?
part, right?
Yeah,
So
yeah. Let's
so
move on with other instructions. So,
okay.
yeah,
So you know this, right? So
yeah,
it's
I know.
fairly
Yeah, it's clear.
and you know what shift 8, shift 4, right? So
Yep, yep, I know.
okay. So it's just shift at 4. So if
So
it's four
it.
zero, you just take out the fours,
Hmm.
get the zeros, right?
Yep.
And then so first hex is just extracting, getting the first
X.
thing of the decimal,
Yep.
and then um last two hex is getting the
Mm.
last two thing, right? And
Wait
then
up,
we are
wait up.
comparing.
First X is
We are
uh
getting the first thing, the F.
okay. So the 4-bit value.
No, the N, right? The
Yeah,
4-bit
this
N.
nibble, this
Yeah,
N.
the nibble, right?
Yep.
And then last two is the KK.
KK. Yeah.
Okay, so now if you
Uh,
go to the code, now you understand that part already. That's
yeah.
very simple.
Yep.
Now, if you go to the first hex, you can see I'm trying to compare the hex. You see, right?
Yep. First X
Yeah,
with this 006.
line 7. Yeah. and then if you do if opcode, right, you clear the screen. Okay, now
Hmm.
you can just scroll down to the docs on the dock.
Wait.
I think if you get the 1997 docs, it will be very easy to do.
Yeah,
Then
but
free code.
it doesn't seem to be opening for me. I do have. So I tried to open it up. You are talking about this link, right?
Yeah, yeah. Brave,
Yeah. It's,
Brave. Let's
uh,
uh,
I can.
try Firefox.
Yeah, wait. I can do it, but let's just hope it doesn't messes up the RAM of my computer. Okay, so it's already starting to lag.
Is my microphone too loud? You can tell me if it can decrease or something.
No, it's all right. I can decrease the volume from here, so it's all right.
All right, all right.
Mm, Let me turn off this plugin. Maybe then it will open up.
So how's your course going? Like you were doing
The
some
Nand2Tetris one.
course.
The Nand2Tetris one.
Mm-hmm.
Oh,
So you
yeah.
get 404.
Yeah, it is not opening up.
I think you have firewall, so it doesn't allow because the author just upload the website from port forwarding. So
Wait, let me also turn off this uBlock, maybe. Mm, how can I disable it? Is this? No. Mm, Privacy badger. What the heck?
okay, it's okay. Never mind.
All right.
If it doesn't work, you can just use the free
Hmm.
code camp. So scroll down on free code camp.
Wait. Wait.
Go to so I'm just telling the basic construct of my program so you can figure it out later.
Hmm.
I'm just explaining the complicated part for you.
Yeah, sure.
Okay, so go down, 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 down.
In the code or in the block?
The block.
Okay.
Um, so right here. So you see the renderer, right? So we clear the screen, right?
Hmm.
After that, you can just now you can just figure it by yourself now, so you
Yeah.
can see how it works, right? Now you
Hmm.
understand
Yeah. Yeah.
how things work, right?
Yeah.
Now it's fairly easy if this hex do this, if that hex do that, you know.
Yeah. Yeah.
Okay, so in the blog there will be explanation there, so you can see.
Sure.
But then it do a shitty job to explain to, so you might figure out something. You might print or use debugger, but as
Hmm.
I said, if you want to feel the pain, go
Yeah.
through it.
Yeah, it's okay. I will check it out because I just need to
Okay.
know which instructions do what exactly inside the memory. So after that, maybe
So
I will be able to debug it. So
yeah, they'll just explain how what code does, but they don't explain what it's really doing. So
okay, so it
feel free
doesn't
to
really
figure it out
explain
on
what is
your own.
happening under the hood, right?
Yeah, yeah,
So
yeah.
yeah, all right. Check it out.
So okay, see you, man. Figure it yourself.
Yeah,
Do
sure.
it yourself. Fix the bug.
Yeah, sure.
In hands of thank you for you.
It doesn't matter because I also like this kind of stuff. And I
Okay, sure. So I'll watch your stream. I'll be there.
sure,
So
sure,
see you.
sure, sure, sure. Yeah, bye. Okay, let's see. Void repeating, we should create x and y, x value, the y value. For example, if we have this, the high byte would be this and low byte is 60. Enable the lower 4 bits. Yeah, see you, man. Therefore, in this example, x is equal to x04 and y is 6. Okay, this is the x value and this is the y value. That's what we extract here. Right. Okay, let's see for the cases. If we bitwise and that instruction with hex value this, and we'll end up with this bit, this byte. Shift that 8 bits right, so we'll get x value. Cool. Same thing with y and with, okay, and we shift that 4 bytes. We'll get, now the fun part, logic. We are grabbing the upper 4 bits of the most significant byte of the opcode. Okay, we can narrow down the 4 different opcodes by the very first nibble. So this nibble will be helpful in figuring out which instruction it is. Yeah, so if it is 0, 0, wait, it is 0 for all of this 3 types of instruction: call, display and flow. So flow is basically your return. Good. Okay, so in this case, first we are getting the first hex, which will give us this nibble, and after that we are grabbing the last 2 hex values, this 2 parts. So if the first hex is 0000, well, it will be for this 3 cases. So after that, if the opcode is this, means the opcode is this, then in that case we need to do renderer.clear. Okay, but if the opcode is this, then we want to stack, do self.stack pop. Now why do we pop from the stack? Let's see. This opcode can be ignored. Okay, let's just ignore it. And what does it signifies? Call, clear the display. Self.renderer. Let's go to renderer to see what it actually does. We are passing the renderer. Mm, we're getting the render from renderer. Okay, so we'll have to open up this file, renderer.py. So I guess this takes care of the screen, so we don't really need to check it out. Let's go back to CPU and instruction. Where were we? Instruction opcode. Yeah, we were at this tab. Pop the last element in the stack array and store it in this subroutine. Okay. What are we initializing in this stack memory? Where is it? It is over here, but what are we passing to the stack? Okay, we are not passing anything in this load ROM in cycle as well. We're not passing anything. Okay. Then what are we popping in this case? Okay, so right now the stack is empty, but maybe when we call a function or a subroutine, in that case it will be having the return. Let's say this is EE in case of return, so yeah, it will have the return address. So let's just assume this works. Subtracts 1 from the stack pointer. What? Yeah, of course it, because when we pop something we need to subtract the stack pointer. So yeah, that is correct. But thanks to our stack array, we don't need to worry about where the top of the stack is, since it's handled by the array. Okay, so we don't need to do this step, subtract 1, because apparently, but this is for the JavaScript stack, but will it be same for the stack as well? Yeah, of course, because when we call this pop, it will pop it and it will remove from the array as well. So yeah, it's safe to assume that it works. Let's move on to the next instruction, which is what? Jump address. But then what really is happening is the score of the computer. So in this case our score should increase, but it is not increasing. So what should be the problem? Let's see. So there might be a particular instruction which is not being executed, and let's see which one is not executed. Okay, before we do that, let's continue with this. Maybe something will show up for this instructions. Where were we? Okay, set the program counter to the value stored in NNN. Okay. Now for 2NN call address. Okay. For this technical reference, say that we have to increment the stack pointer so that it points to the current value of this dot program counter. Again, we are not using a stack pointer. Yeah. So instead of incrementing that, we just use push this dot pc on the stack, which will give us the same result. Oh fuck. Yeah, so when we do this dot stack dot push, it will store the return address on the stack. Okay. We are using stack dot append in this case. Is it correct? Let me check it out. Append add list items. Append, what does it do? End of the list. Okay, so yeah, it will work for the stack. So we append the return address, which is stored inside the program counter on the stack, and after that we change the value of program counter. Good. So seems to be no problem with the call instruction. Let's check this. This is where our x value we calculated above comes into play. Which x value is referring? What is this instruction? 3x kk 3x. Okay, it is if vx is equal to nn, value of x. Okay, yeah, got it. He's referring to this as x value. Good. So let's see what we are doing. Where is it? Yeah, it's over here. The instruction compares the value stored in x the value kk. Note that v signifies a register and the value following it, in this case x, is the register number. Oh, x is the register number, so it is like a pointer or something. Okay. So what are we really storing inside x? We're storing this x value. The x value is not really a value, but is it is a pointer to a location where actually the value x is stored, right? Good. And how do we get this value? Using v dot self dot v x. Right. So this is like a register memory or something. Okay, this seems to be correct as well. This KK portion, this is the KK portion. Okay. And the next instruction is just for where is it? Wait up. Yeah. So the 4xkk1 instruction, it just checks for if it is not equal to. This seems correct as well. How about this instruction? 5xy0. Let's check it out. 5xy0. It checks if x is equal to vy or not. Yeah, so it seems fairly simple. What about this 6xkk? Okay, this is for setting the value of vx to the value kk. Okay, how are we setting it? First we select self.vx and we wrap the kk part using this. Good. This will store the value 7xkk adds kk to vx. What's the difference between this and this? It is the add instruction. So what do we do when we add? Vx is equal to plus. Okay, fairly simple. For this it is load. Let me take a 1 minute break. I'll be right back, guys. You know what, guys? Instead of taking a 1 minute break, I think I will be taking a break for lunch right now. So we'll continue after the lunch. I'll be right back. Hello.